Let's talk about the best time to buy and sell stock with this LeetCode problem. So it's a top interview 150 question, pretty cool. We have a class solution, and inside of it we have our method right here. We are given an array of prices, an int array, where prices at the specific index is the price of given stock on the specific day. We want to maximize our profit by choosing a single day to buy one stock, and choosing a different day in the future to sell that stock. We want to return the maximum profit that we can achieve from the transaction, and if we can't achieve any profit, we should return 0. So it's going to be an integer return. We were given an example here, so if we have something like this, our output should be 5 because we have this 1 here, this 6 here. We're returning the difference basically. And then the 7 right here, it's before R1, and on day 2, selling on day 1 is not allowed because we must buy before we sell, so this has to be kind of excluded from our possible result for the highest thing we can sell it for. So what I'm going to do is I'm going to set our first price that we need to buy our books at the 0th index. I looked at this and our price length has to at least be 1, so we don't have to do a bounds checking for that. So let's make an int, and I'll just say that our buy is going to be equal to the prices at index 0. And our sell will currently just equal to 0. I want to return our sell when we're done with this. So sell is 0, and hopefully we can get some difference so that we can sell at a higher price. Now we're going to want to go through our entire array. That way we can look at each of these values and try to find the smallest one so that we can sell it for the largest value after that. Let's do this in a for loop. So we'll do for int, we'll do a is equal to, and since prices already starts at 0, let's start it at 1. That way we don't have to go through that first iteration. There's no need. We're going to run a as long as it's less than our prices dot length, and then we're going to have our a plus plus. What this a is basically the day we're going through here. So if you want, you could actually rename this to day to make it a little bit make more sense. So this is going through all the days here, and we want to compare that to the previous ones. So inside of here, this for loop, we need to find the minimum prices. You can use an if statement, or you can use a Math.min, which accepts 2 parameters, or accepts multiple parameters, and it returns the smallest one. So we have Math.min, and we want to have our current buy, and we want to see if our buy is greater, or if the element at our current index is greater. So that'll be prices at our current day. And this is going to be stored in our buy. So buy is going to be equal to our Math.min, where we have buy or prices at the specific day. If this price at the specific day that we're looking at is lower, well, we have a new buy. Now, every time we do this, we need to redo our sell. And we need to update it because let's say that this was not here, right? Like this was some larger value. That means this would be our smallest value. Well, this would be our smallest value. And let's say that this was like some huge value. If this was a small value and this was a huge value, well, we could just buy here and sell here. But if this one is smaller, we can't sell here anymore. So we're going to have to update our sell every single time that this goes to another buy, because we can only look at things after this. So that for our sell. So every time this for loop runs, we need to update our sell. We'll do sell is equal to, so we have to reassign, and we're going to do our Math.max because we want to sell for the maximum value, and we are going to have our current sell. So right now at the 0th index is going to be 0, and we're going to compare that current sell to our current price, so the price at this day, and then we're going to subtract from it our current buy. And if we have something like this, we'll just use this as an example right here. We're going to go through this one time. Our prices, the current buy price is going to be, we'll say 7, and then our current sell price is going to be 0. And we go through this, right, and we want to update our buy because we have a new minimum value. It's going to be this 1. And then our sell should update as well. Our Math.max is going to be the cell value, or the prices at our current day minus by prices at the current day. Well, day is 1, so we have 1 minus 0. We're able to sell for 1, and it's equal. And this actually works because if our profit is 0, we want to return 0, and 1 minus 1, if that was completely it stopped right here, we would return 0. Now let's keep going. We go through this again. We're not going to update our buy because none of these are a new minimum, but we're going to update our sell because sell is equal to a Math.max, our current sell, which is 1 right now, or we are going to have a new price day, which would be 5 minus our buy. Well, buy is 1, so this is going to be 4. So our new sell is the value 4, so we would return 4, but we still have more to look at. We're not going to update of this 3 because 3 minus 4, well, it's going to be a -1, right? And our sell is a positive, so obviously sell, which is 4, is going to stay. Now we have this 6 right here. We would have 6 minus our 1, that's going to give us 5. So we're going to replace this with a 5. And then we would return 5. So if we were to run this code, this input example 1 is actually our test case. Our output is 5, expected is 5. We've done that great. Now we have 2 milliseconds of runtime. Our memory is quite high. A way that we can bring this down though is right before our return, do a system.gc to invoke the garbage collection. Let's try to get this 2 milliseconds and 61 milliseconds a bit lower after I put a semicolon, because I always forget the semicolons. And with that done, we have 6 milliseconds of runtime. So that takes a little bit longer, as you can see if we remove it, but our memory is a little bit better. So 6 milliseconds, 53.34. So it's kind of a trade-off on which one you're going to want to use for this code, but I would use the garbage collection at the end. That's going to be it for this Java LeetCode. If you have any questions, as always, please leave a comment below. And if you want more practice, check out that playlist below the like button.